Good morning, all of you. My name is Saikara. I am your chemistry lecturer. Today we will discuss particle nature of electromagnetic radiation. In our last class, we discussed wave nature of electromagnetic radiation. We know that wave nature of electromagnetic radiation can explain all properties of radiation. They are reflection, refraction, dispersion, diffraction, interference. But the wave nature of electromagnetic radiation couldn't explain these phenomena. They are blackbody radiation, photoelectric effect, heat capacity of solids as a function of temperature, and line spectrum of atom with reference to hydrogen. These phenomena can be explained by particle nature of electromagnetic radiation. Let's see one by one in detail. In this four, the third one is not in our syllabus. So first, I will give you a small introduction. Heat capacity. It is nothing but the amount of heat is required to raise the temperature by 1 degree of a given mass of substance. For example, this is iron block. Initial temperature of this is 25 degrees. Now, I want to increase the temperature to 26 degrees. The difference is 1 degree. For this 1 degree, how much heat is required? That is called heat capacity. It is represented with C. C equals to dQ by dt. dQ is the amount of heat. dt is the change of temperature, that is 1 degree. Heat capacity is different for different solids and it is depends on temperature. Now come to the blackbody radiation. Now the question is, what is blackbody? An ideal body which emit and absorb the radiation of all frequencies, called blackbody. In our last class, we discussed electromagnetic spectrum. That spectrum contains different radiations. That all radiations absorbed and emitted by this body, called blackbody. The radiation is emitted by such body is called blackbody radiation. There is no existence of blackbody in our nature. Now, I will try to make a blackbody. I took a hollow sphere. Inside of this sphere coated with platinum black. The walls of the sphere contains small hole. Now it acts as a nearly black body. Let's see one example. I am taking one iron rod. Now I am supplying some temperature. Initially this shows red light. Now I am increasing the temperature. Red light converts into white light. Now keeps on increasing the temperature. White light changes into blue light. This red light and blue light are present in visible region. Visible region contains VGR. This is the increasing the wavelength. Red light contains maximum wavelength. Blue light contains less wavelength. When I am increasing the temperature, wavelength shifts lesser side. Let's understand this with graph. Intensity versus wavelength. At temperature T1, the graph like this. At T1. And this is the at this wavelength, intensity reaches maximum. Now I am increasing the temperature T1 to T2. T2 is greater than T1. Graph like this. At this point, intensity reaches maximum. This is the wavelength. This is lambda 1. This is lambda 2. Initial temperature T1. This is the lambda value, wavelength. Wavelength is maximum. Now I am increasing the temperature. Intensity reaches maximum. Wavelength shifts towards lesser side. For example, when compared to this is the red light. I am supplying initial temperature T1, it shows red light. Now I am increasing the temperature, it shows blue light. Wavelength, for example, this is 700 nanometers. This is 500 nanometers. Wavelength shifts towards lesser side. Why this shows different intensities? Why they can't show same intensities? This was explained by Max Planck by Planck's quantum theory. This theory supports particle nature of electromagnetic radiation. It successfully explains the blackbody radiation, the emission and absorbed radiation due to the vibration of charged particles in a body. For example, this is iron rod. I am considering this particle and this particle and this particle of rod. These three particles have different vibrations, due to which they absorb different energies. For example, this particle absorbs 5 quantas energy, this particle absorbs 3 quantas, this particle 2 quantas. They emit same energy in the form of radiations, due to which different intensities are formed. And the radiation is associated with definite amount of energy, which means it contains fixed amount of energy. According to this theory, the energy absorbed or emitted discontinuously in the form of small packets called quantum. For example, this is the source of light. The energy transmitted discontinuously in the form of small packets like this called quantum. The energy of each quantum is directly proportional to the frequency of radiation. That is, E directly proportional to the nu. I want to remove this proportionality sign, a constant will come, that is equals to h nu. Here, E is the energy of quantum, h is the Planck's constant, that is equals to 6.625 into 10 to the power of minus 27 erg second, or 6.625 into 10 to the power of minus 34 joule second. And nu is the frequency of radiation. We know that nu is equals to C by lambda. From this, E is equals to hc by lambda. Here, C is the speed of light. Lambda is the wavelength in angstroms. A body can absorb or emit energy integral multiple of quantum. That is, E is equals to N h nu. Here, N is equals to 1, 2, 3 and so on. For example, in this case, this particle absorbs 5 quantas energy. E is equals to 5 h nu. Similarly, 3 h nu. In this, 2 h nu. This is called quantization of energy. Now come to the Einstein approach towards Planck's quantum theory. In case of light radiation, a body can emit or absorb energy in the form of small packets called photon. The speed of photon is equals to the speed of light, that is equals to 3 into 10 to the power of 8 meter per second. The energy of photon is equals to E is equals to h nu. The energy possessed by one photon is equals to E is equals to 1 into h nu. The energy possessed by n photons is equals to n h nu. That is hc by lambda. That is n h c by lambda. The energy possessed by 1 mole of photon. We know that 1 mole of photon means Avogadro number of particles. 1 mole of photon energy is equals to Avogadro number of h nu. That is equals to Avogadro number into h c by lambda. We know that Avogadro number is equals to 6.022 into 10 to the power of 23. The units of energy is SI unit is joules, and other units are electron volts. The relation between these two is 1 electron volt is equals to 1.6 into 10 to the power of minus 19 joules. Now come to the photoelectric effect. When a beam of light with suitable wavelength falls on alkali metal surface, electrons are ejected from the metal surface. This phenomena is called photoelectric effect, and these electrons are called photoelectrons. Let's see. This is the alkali metal surface. Generally used metals are potassium, rubidium, cesium. When beam of light falls on this metal surface, electrons are ejected from the metal surface. This phenomena is called photoelectric effect. There is no time lag between light falls on this metal surface and ejection of electrons. Let's see the experiment of this photoelectric effect. This plate is photosensitive plate made up of potassium, rubidium and cesium. The plate which is connected to the negative terminal of the battery which carries negative charge. We call it as cathode. The plate which is connected to the positive terminal of the battery which carries positive charge. We call it as anode. This is ammeter used for measuring the current. Initially, there is no current present on it. By supplying the beam of light from source, electrons are ejected from this metal surface because these are alkali metals. Same direction of electrons indicating the flow of current. Now, current is flowing. Ammeter shows positive indication. The mathematical expression of photoelectric effect is E is equals to W naught plus kinetic energy. Here E is the energy of incident light, that is equals to h nu. H nu is the frequency of incident light, and here W naught is the work function or threshold energy. It is nothing but the minimum energy is required to remove the electron from outermost shell, which means the minimum energy is required to break the force of attraction between nucleus and the electron, is called threshold energy. Each element have certain threshold energy. It is the characteristic property of each element. It is equals to the h nu naught. It is the minimum frequency used to eject the electron from the metal surface. Now, this is kinetic energy, that equals to half mv square. It is a part of the energy in the incident light is used for ejection of electron, and remaining part of the energy is used for increasing the kinetic energy of electron. Then only electron will move. The kinetic energy is directly proportional to the frequency. Frequency is nothing but the energy of one photon, because one photon is enough to eject the one electron. So it is also called as one photon, one electron emission. The energy of one photon is more, some energy used to eject the electron, remaining energy is used to increase the kinetic energy of electron. Then only electron will move. The number of electrons ejected is directly proportional to the intensity. Now the question is, what is intensity? Intensity is nothing but the power transfer per unit area. For example, this is unit area. The power transferred this unit area is called intensity. In another word, intensity is nothing but brightness of light. Intensity is more, number of photons is more. Number of photons is more, number of electrons ejection is more. Now, E is equals to h nu, frequency of incident light. W naught is equals to work function or threshold energy, that equals to threshold frequency, that is h nu naught plus kinetic energy. From this, kinetic energy is equals to h nu minus h nu naught. Kinetic energy is equals to h nu minus nu naught. Let's see the conditions of photoelectric effect. If incident frequency is greater than the threshold frequency, then only photoelectric effect will observe. If incident frequency is equal to the threshold frequency, electrons will eject. If incident frequency is less than the threshold frequency, there is no possibility of photoelectric effect. Now come to the one more terminology, stopping potential. It is indicated with V0. It is nothing but the minimum potential is required to stop the flow of current. For example, these two are electrodes. Now electron is moving here with kinetic energy. This length is equals to kinetic energy. Initially this negative, this positive charge. Now I am changing this charge to negative and this is positive. Immediately this electron experiences some repulsions, due to which it moves towards backside. When this electron reaches here, that is the minimum potential required to stop this photoelectric current. This minimum potential is equals to the kinetic energy. So E V0, stopping potential, is equals to kinetic energy. Let's see the graphs related to photoelectric effect. Graphs. First graph is kinetic energy versus intensity. Kinetic energy does not depend on intensity. So graph comes like this. There is no effect on it. Now come to we know that equation H nu is equals to H nu naught plus kinetic energy. Here kinetic energy is equals to H nu minus H nu naught. This is Y is equals to mx minus c. This graphs like this. The negative intercept indicates the on y-axis kinetic energy, on x-axis nu. Here m is the slope. The negative intercept indicates the straight line starting from negative values of y-axis. This value is indicating the threshold energy or threshold frequency. This is energy required to eject the electron. This energy equals to threshold energy. After that, this energy is used for kinetic energy. Let's see one more graph. Kinetic energy equals to, from this, H takes as common, mu minus mu naught. This graph likes this. Kinetic energy on y-axis, mu minus mu naught. This difference. This means instant frequency minus threshold frequency. Then this energy completely used for kinetic energy. This is y is equals to mx. This straight line passing through the origin. This is the third graph. That's it today class. In our next class we will discuss atomic spectra.